This video will begin our discussion of another special triangle that's going to show itself a whole lot in our circle when we do revolutions. And this is a 45, 45, 90 degree triangle, which means these are both 45, right? And then we have our 90 degree. So how I'm going to do this is, let's call this hypotenuse 1. And there's a reason for this, which we'll learn, I think, in the next video, actually, why we care about that being a 1. But with a 45, if the angles are the same, then the sides that are corresponding with them will also be the same, giving us an isosceles triangle. This is going to help us figure out what that x should be anytime this happens. So how we figure this out, again, is the Pythagorean theorem. X squared plus x squared, that's the legs, equals 1 squared, which means 2x squared is equal to 1. Right? I added these two like terms. One of something plus one of something is 2 of something. I divide both sides by 2, and I get x squared equals 1/2. Take the square root, and then I know from college algebra or pre-calc 1 that this ends up being a square root of 1/2. Now, as you go up in calculus, we start caring less about numbers and where radicals are, but for now, you guys are used to this, and there's a reason, and eventually it'll go away. But what we're going to do is, okay, I split my square root, and I can see, okay, the square root of 1, that's nice, that's 1, and then it's over the square root of 2. That's a great answer, and eventually you'll be able to just leave it. But there's a reason. It links back to what is called a slide rule, which is this old calculator that would help us calculate before calculators, and it would have a hard time dividing by radicals. That's all it was. It used logarithms to do it. If you're curious, you can YouTube slide rule and learn how to use one. It's pretty neat. But it had a hard time dividing by square roots, so what we would do is get our square root out of our denominators. How would we do that? Is we're going to multiply by a 1, which we do often, right? This one idea that it's going to look different, but it's the same. I'm going to put square root of 2 over square root of 2. Inside there's a 1, so when I multiply, it doesn't change my number, but it's going to make it look different. 1 times the square root of 2 is 2, and then on the bottom, I'm going to get square root of 2 times the square root of 2, which is square root of 4, which is 2. All right, so I know that these things are the square root of 2 over 2. And since it's a 45, 45, those sides are the exact same. So again, we can put this triangle to focus on revolution. So you can see this first one, I used the red there for 45 degree. And we know this from previous videos that 45 degrees is the same as pi over 4. We're going to get that these sides are exactly the same. Given that this is a 1, like we did, this is going to be square root of 2. And then this is also square root of 2 over 2. Now, by our previous video, when I do revolutions like this, like revolving here, I can see that this side is going to be the same as this side, right? So I can fill that in. Square root of 2 over 2. And then, again, like the last video, we can see that these are also symmetric going down. So all those are going to have a square root of 2 over 2 as well. But since it's going down, it's going to be a negative square root of 2 on both of those. Right? And then also for this line here, we can see that it's exactly the same line as the one next to it, which means this is the square root of 2 over 2, except for since it's to the left, remember x is to the left, are negative. So it gives me all those sides of the triangles. All these are 1s, but I have 4 different revolution spots for this type of triangle. What I want you to notice, let me highlight in a consistent color so you can see it. This pi over 4 here, this 3 pi over 4 here, this 5 pi over 4, and the 7 pi over 4. Remember, these are all the radian measurements. Notice the consistency that they have is it's all over 4, right? They're all over 4. So anytime we have a 45 degree, that's the actual angle that's going to create here, right, for each base. Anytime I have that 45 degrees or something over 4, right? Oops, I do that sometimes, and then it takes me a while to remember how to get it back. I'm glad I remembered. Something over 4, so I could put k pi over 4, but we'll just keep notes consistent. Anytime it's over 4, my side is going to be, or the way I think about it, actually, is remember the other ones I said, tall triangle, and then that was for the pi over 3s, and then over 6s was the short triangle. What we call this one is the mid triangle. The mid triangle, right in the middle, that's why I call it the mid, it is the same on both sides, and it's going to be the radical 2 over 2 on both sides. All we have to determine is which way is it going. If it's going down, then it's a negative here. If it's going to the left here, then it is a negative. So what's really nice about this is if you looked over the last 2 videos, we've had 3 values. That's it. 4 values, I guess, if you count 1. We have 1, then we have 1/2, then we have radical 2 over 2, and then we have radical 3 over 2. These are the only values that show up on the angles that we have talked about. And we have actually talked about all the special angles except for the quadrantals, which we'll get to as we explain what we're actually going to do with this. Why do we care that I can take a revolution, draw a triangle, and talk about its sides? But these are the 4 values that you'll have to memorize and know which ones they go with. What I would do is maybe list out all your degree radians, pick a random radian, and ask yourself, is it a short, mid, or tall triangle? That is a good practice before going on to the next video. The next video is going to start applying all this. So before you go on, I need you to spend some mental time, right? Pick a angle from your unit circle that you did, from the angles that we did in the previous videos, in the previous lesson, I mean. Take a random angle and then ask yourself, is it a short triangle, a middle triangle, or a tall triangle? This is scaffolding to the unit circle that I'm going to try to make this as easy as possible for you to get it down and then retain it. The biggest thing for trigonometry that I see is while people go through it, it's not that big of a deal. And then they get up to me again for Calc 3 and all of it was gone. So we got to put the time in on how to figure out how to get these down when you haven't touched them for 6 months or 8 months, because that's going to happen, and then they're going to expect you to know these kind of things. Okay, so we're going to take these 2 different types of triangles, 30, 60, 90, and we're going to put them in the circle, and we're going to do some trig stuff with them. So maybe take a break, get these down, these 2 different triangles and what they look like and what kind of sides they produce, where they're at, and then move on to, I'm going to just, in the next couple of videos, I'm going to tell you what sine and cosine are. If you can understand the last 2 videos with these special triangles, and you know all your angles and radians and where they're at, you are done practically. I'm going to show you one little thing to piece it all together after we figure out what they are, and you're going to be able to do some crazy unit circle stuff just based on reasoning. So please trust me, get your angles down, put some time in that because it's going to be extremely important.